So far, we showed that the inverse hyperbolic sine of x is ln of x plus square root of x squared plus 1. Now let's take a look at our cosine. So we want to prove that the inverse hyperbolic cosine of x is ln of x plus square root of x squared minus 1. Okay, let us begin. So suppose, let me use a different color. Let y be inverse hyperbolic cosine of x. So what's the meaning of that? It means that y is equal to ln of x plus square root of x squared minus 1 eventually. We want to prove this part. So since y is equal to inverse hyperbolic cosine of x, by definition of inverse, x is equal to hyperbolic cosine of y. But what is the definition of hyperbolic cosine? Recall that hyperbolic cosine of u is equal to e to power u plus e to power minus u divided by 2. So my x on the left-hand side can be written as e to power y plus e to power minus y divided by 2. Now we're going to do algebra and isolate our y. By algebra, our goal is to isolate y. Let us begin, everyone. So multiply everything by 2. 2x is equal to e to power y plus e to power minus y. We can take common denominator between these two as well. But how? 2x is equal to e to power y plus 1 over e to power y. Very good. So 2x can be written as e to power 2y plus 1 divided by e to power y. Now multiply e to power y and 2x. 2x e to power y is equal to e to power 2y plus 1. Bring 2x e to power y to the other side to form a quadratic equation. So you get e to power 2y minus 2x e to power y plus 1 equal to 0. This is a quadratic equation. How do we see that? This can be written as e to power y to the second power minus 2x e to power y plus 1 equal to 0. If I use u sub for wherever I see e to power y and write down u, wherever I see e to power y, I write down u, I get this. I get u squared minus 2xu plus 1 equal to 0. So my u can be written as, if I have a u squared, so let me write the formula down before I jump into next step. If I have a u squared plus bu plus c equal to 0, quadratic formula tells me that, hey, u is equal to negative b plus minus square root of b squared minus 4ac divided by 2a. Well, let me just substitute everything here. My u is equal to negative b. But what is b? b is this quantity. Negative 2x is my b. So I have u equals to negative b, which is 2x plus minus square root of b squared, which is 4x squared, minus 4ac, minus 4 times 1 times 1, divided by 2a, which is 2. Now let us simplify this as much as we can. U is equal to 2x plus minus square root of 4, x squared minus 1. I factor out 4 and divide it by 2. So my u is equal to 2x plus minus 2 square root of x squared minus 1 divided by 2. So now if I just cancel out 2, u becomes x plus minus square root of x squared minus 1. since my e to power y is a positive function, I'm going to just work with the positive sign. So I'm going back up here. I have e to power y equals to x plus square root of x squared minus 1. My u was e to power y. I'm just going to substitute that here, right? And then rewrite this as e to power y equals to x plus square root of x squared minus 1. But remember the definition from algebra. If you have e to power, I don't know anything, e to power y equals to a quantity like m, then y is equal to ln of m. So this quantity on the right-hand side is your m. If you take ln of both sides, y is equal to ln of x plus square root of x squared minus 1. So we just showed that if y is equal to inverse hyperbolic cosine of x, then y can be written as ln of x plus square root of x squared minus 1.